Changing forms of equations is often thought of as being one of the hardest things to do in math. The reason being is because you have so many different forms, you have to remember so many different equations, and then you have to remember the steps in order to get there. For example, going from standard to factored form, well, you have to know how to factor. Going from standard to vertex form, you must have to know how to complete the square. To go from factored to vertex, you have to be able to go from factored to standard, and then from standard to complete the square. And then from vertex, you have to be able to, do order of operations. Vertex to factored, you have to go from, vertex to standard, and then from standard to factored. So it's a lot of inconveniences and things to remember. Now, there is a way that you can shortcut this, and the way that you can shortcut this stuff is using Desmos. The way you use Desmos to do these kind of problems, and this works for any multiple choice question where they want you to change the form of a given equation into an equivalent form, okay? So first thing I want to do is type in, say I'm given the standard form x squared minus 5x plus 6. Okay, so I type it in Desmos, y equals x squared minus 5x plus 6. And then it says find its factored form. And it's going to give me answer choices A, B, C, D. I'll actually come in and put another answer. So if it's minus, let's just change this to plus. Say this is answer choice A, this is answer choice B, or if it was a true false. So I'm going to go y equals x plus 2 times x plus 3. And I should get a graph. And you can see the graph I just typed in, the purple one, right, is to the left of my original. Something else you can do, just pull up your tables. And at the very beginning of quadratics, we talked about interesting things in like the rule of 3. So if I can find 3 points that are the same, then I have equivalent functions. Okay, so when x is negative 2, my y value needs to be 0. Well, in my original, when x was 2, y was 20. If you have 1 point that is not the same, then it's not an equivalent form. You just get rid of it. So the x plus 2 piece was not right. Now I want to check and see about the red graph. Well, again, so I can change this from a table. Well, let me delete this one and pull the red up. So again, if I look at the red, think about the concept of it covering up or overlapping. Now, when I say overlap or cover it covers it up completely. It doesn't just touch it, okay? It covers the entire graph. Another thing you can go back and check is pull up a table for each equation, and you can see my given x squared minus 5x plus 6 and the x minus 2, x minus 3. When x is negative 2, y is 20. When x is negative 2, y is 20. When x is negative 1, y is 12. When x is negative 1, y is 12. So that's 2 points. When x is 0, y is 6. When x is 0, y is 6. So there's my 3 points that I need. Say, for example, if you had, your tables weren't as pretty or they weren't lined up as good. So say if x was negative 12, right? And you had to use that point as a reference. Well, you can come in and you can type that particular x value that you want to test. So negative 12 gives you 210, negative 12 also gives you 210. Again, it comes down to the rule of 3. If you have 3 points that are equivalent in two tables, then your functions are equivalent, or the forms of an equation are equivalent. So I know the black, or the original, was equivalent to the factored. Now we'll also want to test it for the vertex. Again, type your form, type your equation in. You can click really quick and you can see it overlap. But just as a safe measure, I like to look at tables, okay? And again, negative 220 in my original, negative 220 in my answer choice, negative 112 in original, negative 112 in answer choice, 0.6 in original, 0.6 in answer choice. So these three are good. All right, so that's kind of how I would approach changing forms of equations. Now this doesn't just work for quadratics, it works for any equation.